Exploring equivalent trigonometric functions. I'm Anil Kumar, and now in this video we'll discuss about even and odd trigonometric functions. Now let me sketch a sine wave first to begin with. Since we're talking about trigonometric functions, it is always the sine wave which we talk about. Now in the sine wave, that is the axis, right? Okay. Now if I draw the y-axis from here, it becomes a sine wave. Do you see that? Now let me make another wave here. Okay, so this time again I'll do a similar sine wave, right? But I'll change the point of my axis. Now again, let me draw the axis for symmetry, which is kind of here. But if I draw my y-axis from this point, it becomes a cosine wave. Do you see that? So in general, we are referring this as sine of x and this as cosine of x. Okay, when I wrote x, let me just write 2 pi here as the time period, okay, and 2 pi here as the time period, and this becomes 1, this is minus 1. So this is 1, this is minus 1. Perfect. So we have a sine wave and a cosine wave right in front of us. Now it becomes easier to answer the question even and odd symmetry. Now, what is even symmetry? Even symmetry in general is when f of, let me write in general, f of minus x is equals to f of x, then we say even symmetry. Is it okay? But if f of minus x is equals to minus of fx, then it means odd symmetry. Perfect. So that is what even and odd symmetry is. So even symmetry is that both values on the left side and on the right side of the y-axis are kind of same, right? That is even symmetry. So you can see from here that if I have x value, for example, pi by 2, well, pi by 2 is 0, so that really doesn't really make much difference. But if I have any value here, then the minus of that value gives me the same value. So basically, you see in a cosine function, it is reflected on y-axis. So this is reflection on y-axis. So from graph, you can make out if it is a reflection on y-axis, then it has even symmetry. However, for the odd symmetry, we have a point of symmetry and things are symmetric about this origin. So they are symmetric about origin. So it has a point symmetry. Do you see that? Now sine, you can see, is odd symmetry. So example of odd symmetry is sine function. So we can write sine of minus x is indeed equals to minus of sine x. You can see that. So if I have pi by 2 here, I get plus 1. But if I have minus pi by 2, I get minus 1, negative of that value, right? So that is how it is. If I have 2 pi, plus or 2 pi minus, you see the same value, right? That is cosine function. So in cosine function, we have cos of minus x is equals to minus of cos x. Correct? Now, since sine is odd and cosine is even, what will be tan? I'm writing tan here. Tan of minus x should be equals to minus of tan x. Since tan, you know, is a ratio of sine divided by cos. Is that okay? So sine is odd, it will return you minus sine x. Cos is even, it will return you plus cos x. So you get minus tan x. So that is how you know tan will be an odd function. Tan of minus x is minus tan x. Now if we are talking about the secondary ratios or the reciprocal functions, then since cos is even function, secant will also be even. So in that case, secant minus x should be equal to, secant x. I wrote this wrong. Cos of minus x should be cos x, right? It is. Secant of minus x should be positive secant x. However, cosecant x should be equal to negative of, cosecant minus x should be negative of cosecant x, and cot minus x should be negative of cot x, correct? Since their reciprocals are odd functions, right? So I hope with this you get a clear idea of which trigonometric functions are even, which are odd, right? So cos is an even function, its reciprocal secant is an even function. However, sine, tan, cosecant and cotangent are odd functions, right? Now I hope that helps, and this information is going to help you to find a lot of equivalent trigonometric functions and even sketch them. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.